See, I get in these conversations sometimes with other people. I generally change the subject. Like, all right, use the following guidelines to sketch that curve: 2x squared over x squared minus 1. Who can tell me for what values is this function undefined? Very good. Vertical asymptotes at x equals 1 and x equals negative 1. How do I determine the horizontal asymptotes? I let the limit go to infinity. And we don't even have to do the work. You can just look at this and tell, as x goes to infinity, what the limit will be. 2. You take the largest term in the numerator, divide by the largest term in the denominator, piece of cake upside down. That is correct. Okay, let's do intercepts. In order to find the y-intercept, I plug in 0 for x. And I get 0 over negative 1, which is 0. In order to find the x-intercept, I set the function equal to 0, which is the same as setting the numerator equal to 0. Where's the top equal to 0? At 0. So it goes through the origin. All right, we've already discovered a little bit of information about this, and that used to be basically all that we used to be able to identify before we knew calculus. Now we know calculus, so we can figure out all this stuff, which is pretty cool. Now I can get an idea of what it looks like and sketch an excellent and accurate graph. Let us take the first derivative. In order to take the first derivative, what rule do I have to use? Quotient, derivative of the top. Times the bottom would be x squared minus 1 minus 2x times 4x, right? Or whoops, I'm sorry. I forgot what the function is. 2x times 2x squared. All over. Great, so I have 4x to the third minus 4x minus 4x to the third over x squared minus 1 quantity squared. What am I left with? True or false? Whoop. True or false? This expression is always negative. False. Why? Right, so the bottom is always positive, but the x, if the x was negative, then this would be positive. If the x was positive, this would be negative, right? Simple as that. So I have to identify where the derivative is undefined, as well as where the derivative is equal to 0. Where's the derivative equal to 0? Where's the top equal to 0? 0. Where's the bottom equal to 0? Negative 1 and positive 1. There you go. We already made the statement. If you plug in negatives, you'll get a positive. If you plug in positives, you'll get a negative. So it looks like we got positive, positive, negative, negative. I already know my intervals of increasing and decreasing, don't I? What are my intervals of increasing? Decreasing? Do I have a local max or a local min? Which one do I have? Max, Y, Karina. Changes from positive to negative, very good. So I have a local maximum, I have no local minimum. Where's the local max occur? 0, plug in 0, you get 0. Pretty good? Second derivative. Oh boy. F double prime. With quotient. Derivative of the top. Negative 4 times x squared minus 1 quantity squared minus the top. If I moved it to the top, I would have to use the product rule with the chain rule. So you either got to use the quotient rule with the chain rule or the product rule with the chain rule. Pick your poison. I like the quotient with the chain because I don't end up with negative exponents in this situation. Whoa. Okay. So minus the top, so plus 4x, times the derivative of the bottom. How do you take the derivative of the bottom? Chain. So we set up u squared and x squared minus 1. So it's 2x and 2u. So we get 4x times x squared minus 1. Over x squared minus 1 to the fourth. The algebra of calculus, here it is. So what do we now need to see? What do we have? Yeah, I have the x squared minus 1s. And so I have this term here, and the term on the bottom. They all have an x squared minus 1, so I can get rid of one of them, right? So factor 1 on the top cancels the 1 on the bottom. So this will reduce to 1. This will go away. This will reduce to 3. You could factor out the 4. It's not going to really do much for us, so I'm just going to leave it there. Negative 4 times x squared is going to be negative 4x squared plus 4 plus 16x over x squared minus 1 to the x squared. Thank you. Off my game. 16x squared and negative 4x squared make 12x squared plus 4 all over is the top ever equal to 0? No. If you were to solve the top equal to 0, you get an imaginary number, correct? Top is always what? Positive, because you're squaring something and then adding 4. It will always be positive. The bottom could be positive or negative. So as I set up my number line for my testing, what are the only values that I include? Plus or minus 1. If I plug in negative 2, I get 4 minus 1 is 3. 3 cubed, 27. That's positive. If I plug in 0, get a negative result. If I plug in 2, positive result. Okay, so what did I just determine? Concavity. So you're concave up from, and you are concave up from, and down from negative 1 to 1. Do you have inflection? At what points? So it looks like you have inflection negative 1 and 1, but those are not part of your original domain, are they? So, well, look, you have asymptotes at 1 and negative 1. The function is undefined at 1 and negative 1. The original domain of this function is all real numbers for x not equal to 1 or negative 1. You can't plug those in. You could use 0, yeah. But the inflection points have to be part of your original domain. We now have enough information to sketch this graph. It's going to be a really nice graph. I'm going to make it a 5 by 5. And like I said, we started off by talking about curiosity. Are you curious what this looks like? And I know, thank you for being honest. I know that you can put yourself in a situation where you're like, hey, I just sketched on my calculator. Again, just think back in time. You don't have the technology. What would Newton do? This is what he would do. And we'll see how accurate he is compared to the calculator. We have vertical asymptotes. -1, +1. We have a horizontal asymptote of 2. What is the only point I can plot? Now, let's look at that part in the middle. Is it going to be facing up or is it going to be facing down? Why? Because it's a local max and it's concave down. So you can look at your indicators. It says it's concave down in between and that it's a local max at that spot. So we already know that this shape goes like that. You may say it's a parabola. Not really. Parabolas will extend forever on both sides. This is held in by -1 and +1. But it's that type of U-shape thing. Okay. So what about the other sides? Well, because it tells us that between -1 and +1, it tells us that it's concave down. It also says that it's a local max that happens at 0, 0. All right, let's look to the left, right over here. Will the graph sit on the top or the bottom? The top. Why? We have 3 indicators. It's concave up. Why else? It's increasing, and you know it does not cross the x-axis, so it couldn't be down there. So we've got those 3 indicators. It's concave up in that region. It's increasing in that region. So on the right side, is it going to sit in the top or bottom? Top again, because it's concave up, it is decreasing, and it does not cross the x-axis there. And so, because I'm super excited, I take out my calculator. Let's go, calculator. Lunch is coming. Come on. Y equals, what do we got? 2x squared divided by the quantity x squared minus 1. And I'm going to make a window of -6 by 6. Because my graph, it looks like I extended a little bit further. I'm going to try to compare it to exactly what I have. You don't look impressed. The horizontal asymptote is not shown because the horizontal asymptote is not part of the graph. It shows the vertical asymptote because it's stupid. Okay? Think, if it showed the horizontal asymptote, it would not be a function, would it? And it can only draw a function. This calculator is confused. It thinks that there's a very steep line there. And it's not able to fully understand. Your TI-84s are able to do it without showing the asymptotes. If you wanted to show the horizontal asymptote, then go ahead and type in 2, and you'll get it. Okay, so we get to a more challenging problem. This is our last one, and you're going to have 2 problems for today. You can add on to your assignment from yesterday, and that'll be it. Now, this was exciting for me because, A, I haven't done this problem with other classes before. You guys are the cream of the crop, and you're super intelligent. And also, I hadn't done this problem before yesterday, or before this morning. So it was the first time. I looked at it and said, I have no idea what that looks like. I don't know. Got nothing. Let's try to start somewhere. Let's look at asymptotes or end behavior. Let's let the limit go to infinity of x minus sine of 2x. Let's just use some logical thinking here. What's the largest value that sine of 2x can be? There are no vertical or horizontal asymptotes because it's not a rational function. It's just going to have some type of end behavior. Well, it's really our rational functions, the one you have as fractions that have that type of behavior. So yes, the maximum value sine of x will be 1. The minimum value would be negative 1. So you're either going to have a very large number minus 1 or a very large number minus negative 1, which is plus 1. So what's that going to end up being either way? Infinity. So as x goes to infinity, this function goes to infinity. Suppose you went to negative infinity, then it would go to negative infinity. So what that tells us before you leave is that it will start down there and it will end up there. So at least we know that. We know that much. For right now, that's it. We'll see you guys in a little bit. Go get some brain food. Okay, we pick up here. We've decided that we know that the function starts down and it finishes up because it goes towards, as it goes towards negative infinity, the limit goes towards negative infinity. And as x goes towards positive infinity, the limit is positive infinity. So that's all we know right now. The intercepts are going to be a little bit tricky. How do we find the y-intercept? Plug in 0 for x. Do you know what the sign of 0 is? 0. And so 0 minus 0 is 0. So that's what we get. What? Well, finding the x-intercepts is different. Because we plugged in 0, we got out 0, we know that 0 is one of the x-intercepts. But if you set this equal to 0, there's not a really nice way of solving x minus sine of 2x equals 0. So, yeah, we just won't do it. There's a different method called Newton's method that would allow us to find that solution actually pretty quickly, but we don't know that yet. Well, if we plugged in 0 for x, and we got out 0 for y, and we know it goes through the origin, right? Like 0, 0 is a point on that. Plug in 0, you get out 0. So therefore, we know that it's an x-intercept and a y-intercept. Okay. All right, so now we get to the meat of things. We go towards the first derivative. What is the first derivative? What's the derivative of x? 1. In order to find the derivative of sine of 2x, what do I have to use? Chain rule. What's the derivative of the inside? 2. The outside? Cosine. Now, we would like to find where that's equal to 0, but we would also like to find where it's positive and negative. We're used to doing interval tests. Interval tests right? Plus 1. And you remember last year you had a really good trigonometry teacher. Thought you had a graph, right? So what's the vertical shape of that graph? Plus 1, so we go up 1. What is the amplitude of that graph? 2. So I go up 2 from there to 3. I go down 2 to negative 1. What is the period? How do I calculate the period? 2 pi divided by b. So 2 pi over 2 is? B is the number in front of the x. So I've got pi is my period. Divide that up into 4 pieces. Pi over 2, pi over 4, and 3 pi over 4. Where does cosine start? Max, min, or middle? It's going to start at the minimum here. Cosine starts at the max or the min. It's going to start at the minimum because it's negative. cross over here, up here. To draw that graph very well. But here's the point. The function is increasing when the derivative is what? Positive. Where is this graph positive? Where it's above the x-axis. So the function is increasing at that spot. That's defined. It will be positive. It will be increasing outside of there. And notice, will this happen again at some point on the graph? Yeah. So there's going to be a repetition here. It's going to be periodic behavior. So we will just find everything between 0 and pi, intervals of increasing and decreasing, all this stuff, just between 0 and pi, and we'll kind of make repetitions after that. So let's find those two spots right here, and I find those spots by taking the derivative and setting it equal to 0. I get negative 2 cosine of 2x is equal to negative 1. How do I solve that? Cosine of 2x is equal to 1/2. Cosine is positive. Maybe you remember from your trig days. How do we solve cosine of 2x equal to 1/2? Where is cosine positive? Which quadrant? All students take calculus. Nice try. You know, excellent work. All math students excel. Nope. All right. Oh yeah. Okay. All math students excel. AMS. All right. Hannah, thank you for allowing us that joy of math. All students take calculus. We're positive in the first quadrant, the fourth quadrant. So inverse cosine of 1/2. What do you get? Where is cosine equal to 1/2? Pi over. We're just taking guesses, aren't we? It's 60 degrees, which is pi over 3. So my reference angle is pi over 3. So when I inverse, I'll get rid of the cosine, and I end up with 2x is equal to, we have pi over 3. And we'll have 2x is equal to my other angle. So this is 2 pi all the way around, or 6 pi over 3. So if all the way around is 6 pi over 3, how much would this be? 5 pi over 3. So I solve by dividing both sides by 2. These locations right here, pi over 6 and 5 pi over 6. We're across the x-axis, so that's going to tell us where it's increasing. So when I inverse cosine of both sides, I come up with these. So I take the 2x. You won't have a problem. I'm extending your learning here so that you can see what they would possibly ask you. Say, is this kind of fine with that? And so you said, I won't ask you. So, would you tell me the interval? That's where the graph is above the x-axis. So decrease 0, 5, 6, 5, 6. drive out local max. Local max is where I change from positive to negative, right? Okay, so now we need to do concavity, and concavity is a lot easier because when we take this derivative, we come up with a much nicer result. Sorry if you're running out of room. I guess if you're okay, got a lot of F double prime. What is the derivative of 1? 0. Derivative of the inside, 2 times the derivative of the outside. Yep. So it'll be a total of 4 sine of 2x. That's my second derivative. Once use the chain rule. The derivative of cosine is negative sine. I'll get rid of the negative, and the 2 on the inside will create a 4. Okay, I'm going to do the same thing. I'm going to look at the graph. Is there any vertical shift to this graph? Nope. What's the amplitude? 4. And what's the period? Pi. And so we start here. Sine starts in the middle, and it go up, down, curve shape. Okay, so the original function is concave up, where the second derivative is positive. Where is this function positive? Where it's above the x-axis from 0 to pi over 2. Concave up from 0 to pi over 2. It's concave down where the second derivative is negative. Where is the second derivative negative? Where it's below the x-axis? Pi over 2 pi. Good. Do we have inflection? Yeah, in fact, I'm going to add a couple more pieces in here. Wouldn't you agree that not only at pi over 2, but at 0 and pi it will change as well? So inflection will happen both at 0, at pi over 2, and pi. Okay, we're done with the heavy lifting. Let's take out our calculators. You're now going to feel like this is cheating, but Newton would have a table of values for sine and cosine that he could use in this type of situation. So don't feel like you're cheating. Our function of 2x, and I'm going to go into my table. In my table, I'll type in these values. We'll start by typing pi over 2, or 1.57. Typing pi, and we get 3.14 pi. Typing 5 pi over 6. We get 3.48. I'm also going to write down this decimal so I can plot it. 5 pi over 6 is 2.6. Pi over 6, I get negative 1.5. Graph. Make it a 10 by 10 graph. We also have pi, which is 3.14. We also have the mass. Again, the point is no idea. Okay. Not a tough class, not anywhere near as tough class, but slightly different than the others. Get them all. I'll also give you your last page of your study guide. Thursday and Friday, you'll have time to work. Monday, you'll have your class. There you go. Key review. Go inside.